Hello everyone, in this video we're going to toggle the LED using timer interrupt. So let's take a look at the clock part. Well, since the timer 1 and GPIOC is right connected to peak clock 2, so all we have to consider about is peak clock 2. But one thing I make sure to take a look at is this part. Well, our peak clock 2 prescaler isn't 1, we're using the division factor 2. So our timer clock frequency are automatically fixed by hardware. Well, the timer clock frequency is set to twice the frequency of the peak clock 2 to which the timers are connected, which means that we set the peak clock 2 to 36 megahertz, but it is automatically fixed by hardware, set to twice the frequency. So our timer 1 clock is 72 megahertz. Well, we're still using the port C13 for the LED part, so I'm not gonna uh, explain this part, which is related to LED. So let's move on to timer configuration right away. Before we jump into the coding part, I'm gonna tell you very quick about the timer, about how the timer works. And so since we set the max value of the timer counter to 5,000, and the LED will change their state every 0.5 second. But if I set this number to 10,000, then the LED will change the state every second, every 1 second. So I'm not gonna go deep, very deep with the calculation part right now, but you're gonna understand how the calculation works while we are doing the coding part. Well, let's enable the timer 1 clock first. Well, you know, the timer 1 clock enable bit is 11, bit 11. So I'm gonna enable this part. So this is one chunk. This is one chunk. So if I transform this number into hexadecimal number, it would be 8, and the rest of them are all 0. So it's gonna be 0, 0, 0, 0, 0, 0, 8, 0, 0. There we go. 0, 0, 0, 0, 0, 8, 0, 0. There we go. Well, let's make the timer 1 frequency to 10 kilohertz. The reason why we use the 10 kilohertz is because of the convenience of the calculation. Because we take the reciprocal of frequency to get the period. So the reciprocal of the 10 kilohertz is 0.1 millisecond, which means that each increment takes 0.1 millisecond. So since our timer 1 frequency is now 72 megahertz, so we need to set the prescaler value like this. Because of this explanation, there is the +1 over here, so we need to subtract 1 in this case. So we're going to set the prescaler with this value. There we go. Now we're gonna set the maximum value for timer. Since our strategy was to make the maximum value to 5,000, and when the counter value hits the maximum value, then every time when they hit the maximum value, the interrupt will occur. So we're gonna set the counter value, the maximum counter value to 5,000 minus 1. Then the reason why I put minus 1 over here is because, well, our counter starts from 0, not 1. So it should be minus 1 over here. Well, we're going to apply the prescaler and auto reload register settings right away. So we need to enable the update generation beat because it says that reinitialize the counter and generates an update of the registers. Note that the prescaler counter is cleared too. The counter is cleared if the IR is 0, up counting. Since our counter will be set with the up counter, so we need to enable this beat over here. So since this register is 16-bit register, so we're going to use 0001. There we go. Because this is one chunk, so there's gonna be 1. And this is one chunk, and this is one chunk, and this is gonna be one chunk. So 0001 if we transform this number into hexadecimal number. Well, like I said before, every time the counter value hits the 5,000, the interrupt will occur every time. So we're going to use the interrupt. So I'm gonna enable the interrupt. So in this register, if you take a look at this beat 0 part, update interrupt enable. So I'm gonna enable this beat over here. So it's gonna be 0001 since this register is 16-bit register as well. Well, now we're going to enable the interrupt request based on the NVIC table over here. If you take a look at this part, the timer 1 update interrupt is on this table over here. We don't need to take care about the timer 10 in this case. So if I get into this table over here, well, we need to copy and find the real parameter. Well, we're going to use this parameter, copy, and paste it over here. So there we go. Well, after that, I'm going to enable the counter, and we're going to set the up counter with this register over here. So if you take a look at this register, well, we're going to put 1 over here to enable the counter. And when it comes to up counter, we have to put 0 over here. So this should be 0. But since the reset value of this register is already 0, so I'm going to use the OR operation in this case. So it's going to be 0001. There we go. Since we're going to use the interrupt in this project, so I'm just gonna write down the infinite while loop over here, and then let's complete this IRQ handler over here. So, well, if you take a look at this register over here, this beat is set by hardware on an update event, which is the event for us is about this interrupt when the counter value hits the 5,000. So, well, we need to check this beat to toggle the LED. So since this beat is beat 0 over here, I'm gonna use the AND operation again to check this beat. So it's gonna be 0001. So if this result of this operation is true, which means that the speed is set by hardware because of the uh, interrupt. So I'm going to clear this beat again. So because of this description over here, it is cleared by software. So we need to clear this beat on our code. So in this case, I'm gonna use AND operation and bit conversion um, operation as well. So it's gonna be like this. Well, to toggle the LED, whenever the interrupt occurs, we need to use the exclusive OR operation in this case. So as you probably can tell, we're using the port C13 for our LED. So you need to toggle this part. So when I turn this number into hexadecimal number, it would be 2. So the entire number, it would be 00002000. There we go. So it's gonna be 00002000. There we go. So this is all about the code today. So if I build this project, well, the build is completed. Well, I just unloaded the code right now, and the LED changes state every 0.5 seconds. So whenever the interrupt occurs, when the counter value hits 5,000 that we set on our code. So I think it pretty works well. This is all about today's tutorial, and I hope you find it very useful through this video. Thanks for watching, and see you on my next video. Bye guys.